So in our last class, we saw the IR model. We need the IR model for designing the searching subsystem, because the searching subsystem is working by interacting with users online, but indexing is offline. There is no interaction from the users during indexing, but during searching, there is an interaction from users because the searching is initiated by the users. When users have an information need, they are asking the search engine, the information retrieval system, for identifying some articles or books relevant for their information need. So searching part is an online process. So it has to be designed systematically such that it's running faster and also it's effective. We have to see it from both efficiency and effectiveness side. No user need a slow system. It has to be as fast as possible. In addition, no user need a system that can't retrieve relevant document. That means effectiveness. So we have to make sure that the system is guided by the right procedures so as to come up with relevant document for the user's query. So towards that, nowadays vector space is the best information retrieval model, because as we said last time, information retrieval model will have mainly three parts. First of all, we have to measure the degree of importance of every index terms for representing a given document. So each term should be measured to what extent they are important for representing a given document. So measuring the importance of term is the first thing for representing the document itself, because documents are finally searched based on the words they contain or terms they contain. How can we measure the importance? Using term frequency multiplied by inverse document frequency. In simple terms, it's called TF-IDF. It's trying to find given a given term, how important is that term within a document using the term frequency, and also how frequently that term is available across the document collection using inverse of the document frequency. Then finally, it's trying to see the importance of the term in a given document and also the occurrence of the term in some of the document. So it gives more relevance if the term is appearing frequently in a given document, but in some of the documents across the collection that you have. If the term has high term frequency and high inverse document frequency, that term is important for representing the document. We can say the term is a stop word or a common word if the term is appearing frequently across the document collection. We can say the term is a read-only one if the term is only near to one appearance in a given document and also near to one appearance across the document collection. So even TF-IDF will give us to measure whether the term is a stop word, a content-bearing word, or a read-only one word. Our major aim is identifying those content-bearing words, words that are frequently appearing in a given document and words that are appearing in some of the document collection. So some, why we say some? Because we can't say exactly this much document. It has to be experimented and identified the range. Some means from what percent to what percent, from 20 to 60 or from 30 to 70. It has to be measured through experiment and decided. The content bearing terms in a given language are appearing across the document collection in this percentage of range. Once the importance of the term is measured, the next step is we have to identify relevant document using partial matching. Because since we are dealing with uncertain world, both the author's world and the reader's world are uncertain for the IR system. It accepts user's query, it attempts to find and identify relevant document from the author's world document collection. So to make it work as much as possible, a given document is relevant for a given query if it contains at least one of the query terms. So a document containing one of the query terms, two of the query terms, all of the query terms should be retrieved as relevant. That's partial matching. So any partially matching document with the query should be retrieved. For that, similarity measurement like cosines are used, such that unless and otherwise, the cosine similarity score is equal to 0, the document should be retrieved as relevant. But once the relevant documents are identified following the partial matching principle, we are not just randomly displaying for the users those relevant documents. We have to apply best matching. So on top of partial matching, we have to apply best matching. Best matching means we have to rank documents as per their importance for that given query. The most important, the most relevant document for a given query is the one with the highest cosine similarity score. So as the cosine similarity score is near to 1, that document is the most relevant one for the query. As the cosine similarity score is near to 0, still the document is relevant, but the least relevant. If the cosine similarity score is 0, the document is irrelevant and it has to be ignored. So all starting from measuring term importance, applying partial matching, then again applying best matching are all applicable in vector space model. Nowadays, probabilistic models are also under investigation because probabilistic model allows to measure, since as we said, we are dealing with uncertain world. For information retrieval, the author world, the reader's world are known. As a result, we have to measure the probability of relevance of a document given query and document I. Then that probability of relevance will tell us the degree of relevance of a given document for the given query. As the probability becomes high, that document is also relevant. In addition, when we are dealing with probabilistic retrieval models, on the one hand, we can see term independence, like vector space model. One of the problem of vector space model is it tries to see each terms because it's measuring the importance of each term, and then it is using that term for measuring the relevance of the document for a given query. So every terms are independently evaluated for representing a document, for measuring the relevance of the document. But if we relate them, one term with another term, That means whenever one term is appearing in that document, what is the next term that's expected also to appear? This will give us a chance for looking at the interdependence between different terms, such that a given document becomes relevant if it contains those related terms appearing within the query. So probabilistic information retrieval models are giving us a chance to see term independent like vector space, and also to relate terms using like Bayesian belief network. Still, that one is a gap, especially for Amharic information retrieval system. It's not still investigated. So anyone with an interest can go for that. Investigating the extent to which Bayesian belief network can be applicable for improving the effectiveness of Amharic information retrieval system. So once the system is designed, the next step is what? So the system is ready, it accepts the user's query. We'll see later on how to improve query also. But for the time being, the system is accepting query, then it searches and retrieve relevant document for that query. So we have to know the effectiveness of the system before making it applicable for the users. So measuring retrieval effectiveness is critical. That means to what extent the system is retrieving relevant document for the users. Information need satisfaction. On the other hand, when we start evaluating a system, we are trying to make sure that the system is working as per the defined objective or not. In addition, we are also making sure that is the system accepted by the users or not. If there are gaps during evaluation, we have to identify which gap should be solved to improve the effectiveness of the information retrieval system. Even we can also compare and contrast one system with another system, such that we can suggest this one is a base system for information retrieval to identify relevant document for the user's query. So basically, evaluations are required to get a feedback concerning the performance effectiveness of the system and to identify the gap that needs further research, further work to improve the performance of the system. Unless we evaluate, we can't understand to what extent the system is working. Whenever you design a system, whenever you do something, you have to evaluate at the end of the day to see to what extent whatever you do is satisfying the purpose that work is done. When we come to our system, as we know, in any system evaluation, we have two levels, user-centered evaluation and also system-centered evaluation. Because when we are looking at any system or software development, there are 4 stages of evaluations: unit testing, integration testing, system testing, user acceptance testing. Unit testing means whenever we write every sentences, and then whenever we write a given function, we have to make sure that that function works well. Then integration testing. What if 2 functions are integrated? Are they working again correctly? Then system testing. At the end of the day, we have a system. We have to test the performance of that system to know its accuracy, to know its relevance, to know it is precision, recall. Then user acceptance testing. At the end of the day, whatever system we design, we are designing for the users. So we have to make sure that the users accepts our system or not. So we have to know to what extent the system is accepted by the users. Is there any feedback that comes from the users to improve the performance of the system? So when we evaluate the IR system at the end of the day, we have to evaluate it from the user-centered point of view and from the system-centered point of view. From the user-centered view, we need the user's comment on the system. We have to have some series of issues that we raise about that system. Mostly, as it is pointed out on ISO, international standard, there are 5 E's. Users have to evaluate the effectiveness of the system. Users have to evaluate the efficiency of the system. Users have to evaluate the easiness to learn the system, the easiness to remember the system, and also error tolerance of the system. From that point of view, how much the system registered, we have to see, and what are the comments given, feedbacks given by the users for improvement, we have to see. Again, before passing it for the user's evaluation, we have to, by ourselves, evaluate the system and know the effectiveness of the system. We have to prepare document corpus. We have to prepare queries, challenging queries, basically. But in fact, easy query, medium query, challenging query. Then relevance judgment. We have to relate queries with document. And we have to consult users, professionals, to relate for us, for this given query, which of the documents are relevant. That means relevant judgment. So we need a matrix, like column-wise, we have queries, maybe 10, 15 queries. Then row-wise, we have the document collections. For each query, the users or professionals have to identify which of the documents are relevant. So as you see on the slide, there are queries column-wise, Q1 up to Qn, and there are documents D1, D2 up to Dm. Obviously, queries are less than the document collection. We may use up to 15 queries. Then for each query, which of the documents are relevant is identified. Like for query 1, document 1 is relevant, document 2 is relevant, maybe document 3 is irrelevant, document 5 is irrelevant, then the last document is relevant. For query 2, the first 2 documents are irrelevant, but maybe the third, the fourth documents are relevant. In this way, for each query we have, in consultation with the users and the professionals, we have to label them. Which of the document is relevant for which of the queries. This relevant judgment will be used later on for evaluating the effectiveness of the IR system. It's like preparing a labeled data set for evaluation. We are not using just one user for relevance judgment. We have to use multiple users. That means K users. And then we have to apply like majority voting. Which of the K users are mostly suggesting for query 1, whether document 1 is relevant or not, document 2 is relevant or not. Accordingly, we can label as per the majority voting what the user suggests, which documents are relevant for which query. Then this one is a base for us for measuring the effectiveness of the system. Why we are using multiple users? Because basically relevance judgment, the term relevance by itself, what's relevant for one person may not be relevant for the other person. Even if we are searching for the same document, if one document is relevant for me that document may be not relevant for the other person because our perception is different, our educational background is different, our interest is different, and we need to read mostly algorithmic book. Somebody maybe wants to read mostly programming books. Others may want to read conceptual books. Others may want to read books with a lot of mathematical manipulation. Even if all of us are interested in information retrieval, the book and article that we want to read is different because of our background, because of our personal subjectivity, because of our information need, because of our motivation internally. So even if such challenges are there, still using K number of users, we have to make relevant judgment that can help us to evaluate the system based on the K users relevant judgment. That will give us at least a feedback to say something about the system itself. So when we are measuring relevant judgment, relevance retrieval effectiveness using the relevance judgment, at the end of the day, the information retrieval systems, even the search engines nowadays, are retrieving four things. They are retrieving relevant, they are retrieving irrelevant document, they are not retrieving relevant document, they are not retrieving irrelevant document. Any search engines or any information retrievals nowadays are bringing document with these four dimensions. Sometimes, in fact, the degree of relevance, maybe the degree of retrieved documents that are relevant, irrelevant, differs from query to query. But in any retrieval scenario, these four situations are happening. Any information retrieval system, retrieve relevant document, retrieve irrelevant document, not retrieved relevant document, not retrieved irrelevant document. That means some of the retrieved documents are true positive, matching with the query. There are also, the last one is not true positive, it is true negative. The major thing we have to concentrate is on the false side, both the false positive and false negative. If the system is retrieving a relevant document and ignoring irrelevant document, that system is the best. But unfortunately, because of the challenges of the author's world, the reader's world, the challenge of the language itself, because natural language is complex, natural language is ambiguous, natural language is incomplete, both lexical, syntactical, semantical, discourse, all are dependent on the speaker. As a result, even within a given language, from place to place, there are differences. What is true for one place may not be true for another place. As a result, any IR system can't retrieve only relevant document, can't ignore only irrelevant document. So it's obvious that false positive and false negative are always happening. False positive means the document is actually irrelevant, but the system retrieved it as relevant. False negative means the document is actually relevant, but the system didn't retrieve it by assuming that the document is irrelevant. So the major thing is, how can we reduce false positive, false negative, and maximize true positive and true negative? Our major aim is maximizing true positive, true negative, and minimizing false positive and false negative. Towards that, we have to understand why false positive is appearing, why false negative is appearing. If we know the cause of false positive, if we know the cause of false negative, we can deal with them accordingly. Mostly, false negatives are appearing. Relevant documents are not retrieved. Why the system is ignoring relevant documents? Because the system is considering them irrelevant. Why such things are happening? Because of synonymous nature of words. Synonymous means there are different words with the same meaning. The document may be written using the word Abyssinia. The users may be searching using Ethiopia. Or the document may be containing 13 months of sunshine. The users are looking for using Ethiopia. The system is automatically ignoring those documents containing Abyssinia, those documents containing 13 months of sunshine. Whenever there are synonymous words that are used for writing a given document, unless and otherwise the words, the query words are available in that document, the system is ignoring them. What should be done? To make the system knows those synonymous words with a given word. Obviously, there are many strategies done by different researchers. But still, when you are dealing with one problem, another problem is appearing. But anyway, we'll see that one during query expansion, how researchers try to deal with false negative and false positive. But the major cause for false negative is why the search engine is not, why the information retrieval system is not retrieving relevant documents is because of the synonymity of words that are appearing in the document. While the user is searching using one word, if there is another word with similar meaning or with similar semantic, unless and otherwise we connect the two words, the system can't get it. The other problem is false positive. The document is actually irrelevant, but the system attempts to retrieve it as relevant. That means what? The query term is in that document, but the document, even if it contains the query term, that document is irrelevant. There are polysemous words, the same word with different meaning. Think of apple. Apple, a document may be discussing about apple fruit, or maybe a document is discussing about Apple computer company, or maybe the document is discussing about Apple business center. Can we say that if the user is searching about Apple fruit, can we say that all the documents that contains Apple are relevant? No, because words have different meaning. Unless and otherwise, we connect what users are looking for with the document, it's very difficult to optimize and make the system ignore irrelevant documents that are containing query terms. So false positives are happening because of polysemous nature of the words. So again, at this point also, we have to deal with like intelligently the system has to understand the meaning. That means it has to start relating one word with another word. If users are searching for apple fruit, unless and otherwise the document is containing apple with fruit, that document should be ignored. That means. Then we make the system concentrate on documents that are containing the query terms only. But that doesn't mean we have to ignore also other documents which may be relevant. I'm searching for apple fruit, but apple is not only the only fruit. There are many others who are fruit. How can we make the system when it's retrieving apple fruit? It has to also retrieve other fruits. So identifying the central concept and revolving around that concept will make to decrease false positive and false negative. But now, this is our confusion matrix when we are evaluating the performance of retrieval system. Using the matrix, how many relevant documents retrieved, how many relevant documents retrieved, how many relevant documents not retrieved, how many not relevant documents not retrieved. Then we can calculate the recall ability of the system, the precision ability of the system. Why we need the relevance judgment is to come up with the confusion matrix that tell us column-wise relevant, irrelevant, row-wise retrieved, not retrieved. Then if you see the diagonal line, that is the false positive end, true positive end, true negative. So we need to achieve the diagonal line, but actually it's very difficult to achieve. Frequently, others B and C also appears. That means what? Irrelevant documents may be retrieved, relevant documents may be ignored. So as much as possible, by analyzing, we have to minimize. To minimize, first of all, we have to know recall precision. Recall means የማስታወስ ችሎታ ማለት ምን ያህሉን ያስታውሳል ካሉት relevant ዶክመንቶች። Recall means the ability of the system to retrieve relevant document from the corpus. How many of the relevant documents available in the corpus are retrieved by the system will give you recall. Retrieve the relevant document out of the total relevant document. How many of the relevant documents are retrieved from the available relevant documents from the corpus will give you recall. Precision measures the preciseness of the system. To what extent the retrieved documents are containing relevant documents. So recall is measuring out of the relevant documents available in the corpus, how many of them are retrieved. Precision helps you to measure out of the retrieved one, how many of them are relevant. So recall is trying to see A over all the relevant documents, A plus C. A over A plus C will give you recall. That means relevant documents retrieved over relevant documents retrieved plus relevant documents not retrieved. Precision tries to measure retrieve relevant documents out of the total retrieved document. When we calculate, again, we take A, relevant documents retrieved, over relevant documents retrieved plus irrelevant documents retrieved, row-wise. A over A plus B will give us precision. A over A plus C will give us recall. Let's see it with example. assume that there are a total of 10 relevant documents in our corpus. And the relevance judgment for the query shows that for the query, document 15 is relevant, document 34 is not relevant, document 45 is relevant, document 8 is not relevant, document 23 is not relevant. So we take the relevance judgment suggested for that query within the collection. And now these are the documents retrieved. Assume that we said for the IR system to retrieve 1 document, to retrieve 2 documents, to retrieve 3 documents. That's possible to say. Let's assume that we need only the document to retrieve 1 document. That means document 15. What is the recall of the system? If it is retrieving only 1 document, and since document 15 is relevant, recall is there are 10 relevant documents. Out of the 10, it remembers 1 of them. Recall is 1/10. What about precision? The system is retrieving 1 document, and that 1 document retrieved is relevant. Precision is 1/1. So recall is 1/10. Precision is 1/1. But now let's increase. Assume that 2 documents are retrieved. Recall is again, recall doesn't change because out of the 2, there is only 1 relevant document. So recall is the same, but precision is now reduced because there are 2 documents retrieved. Out of the 2 documents, 1 of them is relevant, 1 of them is irrelevant. So we are calculating the precision of the system by taking how many relevant documents are retrieved out of the total retrieved. That means 1/2. 1/2 means 0.5. Again, increase to 3. When you are increasing to 3, there are 2 relevant documents retrieved out of the 3. Now recall is increasing because the system identified 2 of the relevant documents when we are increasing the number of documents retrieved. What about precision? Out of the 3 documents retrieved, 2 of them are relevant, so precision is 2/3. Recall is 2 over total relevant document 10.